inside this box, there are going to be two circles. And for our purposes, those two circles, this will be called set A. And then there's going to be another circle that's going to be called set B. Now, when we talk about Venn diagrams, usually we're looking also at intersections of some things. So you can see this other circle that's somehow going to overlap partly with set A. So it looks something like that. Okay? And so I'm going to just write down some numbers in these. Just write down some numbers. So let's suppose I'm going to use set builder notation with this as well, because there are a couple of problems that involve set builder notation with this. So let's suppose that the universe, I'm going to talk about the universal set. You don't know what that is yet, but the universal set. UNIVERSAL. Let's suppose the universal set, universal. Let's suppose the universal set is this. And I'm going to denote it with the letter U. U for universal set. Let's suppose the universal set is this. The set of x's such that, remember the symbol, the set of x's such that x is a natural number. And what are your natural numbers? What's the smallest? 1. 1, 2, 3, 4, and so on. How many are there? An infinite number. And at the same time, x is less than or equal to 12. So that's my universal set. Okay? Now here's what I mean by universal set. So this rectangular box that I drew, see this whole box, don't look at the circles just yet, but this whole box contains the universal set. So how many elements are in my universal set? 2? Why 2? What are they? If you say 2, then you can tell me what they are. What are they? Huh? Where do you get A and B from? That's okay. It's all right. So he says it's A and B. How many elements are in my universal set? Someone else?
Infinite.
12. 12. Not infinite. You see why it's 12? Okay. 12, because this says my universal set contains all the natural numbers that are less than what? Or equal to 12. So on that worksheet you did last week, we talked about this last week, we saw that a good thing to do is actually list, and by the way, this is in set builder notation. We indicated there are times when you may want to write this as a roster. So what is my roster? 1, 2, 3, all the way to what? 12. Now remember the 3 little dots, the ellipsis, that means ellipsis. That means it doesn't go from 3 to 18 and that's it. It goes from 3, 4, 5 all the way, I didn't mean 18, it looks like 18 from here. 12, right? Okay, so how many elements will be in this rectangle? 12. 1, 2, 3, all the way to 12. All right. So that's my universal set. So my universal set is everything that's in here. Is that clear? That's what I mean by universal. Universe. Think universe. Universal. Set B. Let's go about set B. Set A, I'm sorry. Set A. So let's set A be this now. Set A is a set of x's such that x is a natural number and x is a square number less than or equal to 12. So set A, or the elements, set okay, are the elements that are a natural number, and at the same time, it must be a square number that's what? Less equal to 12. Now, here's the thing, you get from a previous course, you have to know what square numbers are. The idea of square numbers mean the same thing as perfect square, by the way. So perfect square, let me make a note of that. Square numbers, perfect square. So from a previous course, just give me an example of a perfect square. What number that's a perfect square, you think? 4. Someone said 9. 9's a perfect square. 4's a perfect square. So remember your perfect squares, and let me see if you know this. What's the smallest perfect square? 1. Smallest perfect square is 1. So your perfect squares are these. One's the smallest. The next one is 4. And here's what you learned about perfect squares. So for example, if I take the number 1 and I square it, 1 times 1 is 1. If I take the number 2 and I square it, 4. Okay? 4. So basically what's happening is this, guys. So let's say you took a rectangle, or these are actually squares. You took a square, and this was 2 inches, and this was 2 inches. How many square inches is in that square? 4. Because remember, the area of a rectangle or square is length times width. So 2 times 2 is 4. Here, that one was 1. So 1 inch by 1 inch is what? 1. The next one would be 3 by 3. What's that? 9. So the next perfect square is 9, because the square root of 9 is what? 3. What's the next perfect square? 16. 4 times 4 is 16. What's the next one? 25. 5 times 5 is 25, and so on. So how many are there? How many are there?
6.
No, okay, I'm sorry. How many perfect squares are there all together? An infinite number. Okay, thank you. You were saying 3 because of the set. How many perfect squares are in set A? 3. That's what you mean by 3. Yes. So I'm going to go ahead and list this in roster notation. So in roster notation, set A is what? 1. What else? No. Perfect square. 2 is not a perfect square. These are your perfect squares right here. 1, 4, 9, 16, 25, 36, and so on. What's the next one? 4. What's the next one?
9.
What, am I done?
Yeah.
Yes, because those are the only ones that are less than or equal to 12. So set A consists of how many elements? 3. They are 1, 4, and 9. Before I put those elements in my Venn diagram, let's go to the next one though, because I know that A and B overlap. So let's talk about B. So B is this. Set builder notation. Set of x's such that x is a natural number and x is even and less than or equal to 12. So B is a set of x's such that B is a natural number, but at the same time, it has to be what kind of natural number? Even and less than or equal to 12. Okay? It helps, now that's set builder notation, it helps if you write it in what notation? Roster. So let's talk about set B as a roster. So in roster notation, what are my elements? 2. What's the next one? 4. Y'all are hesitating with this. It's either, I'm thinking you don't know your even numbers. I'm hoping that's not it. Come on, guys. 2, 4, 6, 8, 10, or the fact that you probably just want to go to take a nap.
Oh,
2, 4, 6, 8, 10, 12, right? Because it said less than or equal to. All right. Now let's talk about how to put those in the Venn diagram. All right. Now listen carefully. You got to understand the different parts of this Venn diagram. So I have these two sets. And set A and set B, this right here that I'm shading in, what do you think that means? That if I had anything in there, what would that mean?
flat for both sets.
Huh? Be a little bit more specific. Yes.
Element for both sets.
Say it again.
Element for the both.
Okay, so that means that if something's in there, that means it's also in A and where else? B. So that means the intersection. So the little shaded region means that's where set A and set B do what? Intersect. Those are the elements they have in common. Okay? So those are the elements they have in common. So that's what that means. So this right here means A intersect B. A intersect B. So that, remember, did we talk about that symbol, the intersect symbol?
No.
Okay, so that symbol that looks like an N means intersect. So A intersect B. So if set A and set B have common elements, that's where they would be located. Okay? All right, so I'm going to ask you this. Look at my roster for A and B. A and B. What should go in that shaded region? 4. 4 is the only element that set A and set B have in common. So 4 has to go here. Now listen, do not, I'm going to put this in pencil so I can erase this, do not put 4 here. Because if you put 4 here, you're saying that 4 is an element of A, which it is, right? But 4 is not what? An element of B. Okay? So where must 4 go? Yeah, where those two circles intersect. So that's 4. Okay? All right, now, how many elements are in this universal set? How many elements in the universal set? 12. All I've done so far was put how many elements in this Venn diagram? 1. The number 4. All right, let's do some more. So look at set A now, guys. Set A had how many elements? 3. Where do you think the elements 1 and 9 go in this Venn diagram? On A, but not where it's shaded. So let's say 1, 4. I'm sorry, I didn't mean 4, I meant what? 9. 1, 9. Y'all agree that's what it looks like so far? Okay, let's talk about B now. B has how many elements? 6? Okay. So that means that I've taken care of 4, right? Taking care of 4, so that means all these other elements have to be located where? In this little part. So I'm going to ask you this. Could I put, let's say, 2 here on the outside? No. What you're doing is you're indicating that 2 is in the universal set, but it's not in A, and it's also not where? In B. That's what that means. So where must 2 go? Inside of B, just not here. Where does 6 go? Inside of B, just not in A. This little part here. 8, 10, and 12. So you agree so far I have this correct? All right. Now let's look at the universal set. What numbers am I missing? 3? All right, so good. 3. Let's talk about 3. So 3 is not listed anywhere in here. So where do I put 3? In the box, just not in a what? Circle. Okay, good. Could be anywhere in the box. Does not matter. Does not matter. 4 is already there. 5. Let's think about 5. Where do I put 5? In the box, just not in the circle. I'm gonna put it here. 6 is already in there. 7. Where do I put 7? In the box. 8, 9, 10, 11. In the box, and then 12. So that's your Venn diagram. All right. Now we're going to use those ideas with these problems we're about to do. And they're not difficult, by the way. They're fairly easy. Okay? All right, you understand how we fill in a Venn diagram? All right. Okay, now listen carefully to this. It's fairly easy to deal with. All right, now listen to this. Go ahead and what we're going to do now is start talking about some operations we can do with sets. Okay, we've already looked at one. We're going to talk about it some more. But one of the operations we can do is, what is this right here? Intersection. That's one of the operations. There are 3 operations that we're going to look at. So 3 set operations. First one is going to be called the complement. Complement. And I spelled it wrong. It's C-O-M-P-L-E-M-E-N-T. Okay. The second is intersection. And the third, now remember, and you probably remember this word from a previous course or background.
Yeah.
We looked at intersection, we're also going to look at what? What'd you say? I thought you said something.
Yeah.
Union. Union. So those are your 3 set operations. They're very easy to deal with. Very easy to deal with. Okay? All right, now, complement. Complement. Okay, I'm gonna talk about complement by using an example. So go ahead and write this down. Write this down. And I'm just going to put one set in there. So I'm going to put, so we don't get confused. Put one set in here. Set A. And in set A, now remember this whole thing's a universal set, right? And this is set A. So in set A, let's say in the universal set I had 1, 2, 3, and inside A I have 4, 7, 8, and over here let's put 1, 2, 3. Let's put 10, 13, 17. So go ahead and write those numbers. All right, now.
That's 12, 13, 17.
Yeah, 1, 2, 3, 13, 10, and 17. That's a 10. Yeah. So it's kind of blurry up here. All right, now let me talk about A complement. It's very easy to see. A complement. So let's talk about the complement. So this is definition of a complement of a set. All right, definition complement of a set. All right, so listen carefully. The complement of a set A, and here's how it's denoted. Now, some textbooks use a different symbol. So we're going to use what your textbook uses. So your textbook uses this. So it's written as A with that little, kind of like that half, what's it called that, not a quotation, that half quotation? I'm not sure what that word is. Okay, apostrophe, all right, we can go with that. Thank you. So it looks like an apostrophe. See how it looks? All right. So that means a what? Complement. Okay, a complement. And here's what it means. It means, so the complement of a set A, which is written like this, is the set of all elements, in the universal set not in A. So write this down. So the definition of a complement, if you're looking at A complement, so you have A in front of you, right? And you have the universal set. So A complement would be everything except what?
Circle.
Except set A, except the elements in A. That's what A complements mean. Everything but set A. So I'm going to kind of shade in pencil what the complement of A is. So here's A. So what do I shade in if I were to color it? Everything that's located where?
Outside the circle.
Outside the circle. So all of this. Okay? So that's what A complement is. Now the problem is that a Venn diagram won't always be given. So if it's given in roster form, then what you would do is you cross out everything that's in A, and then everything else is what? A complement. Okay? So if it's in Venn diagrams, if there's a Venn diagram, then it's easy to deal with. So tell me, in this example here, what is A complement? You guys say A complement equals what? Go ahead. 1, 2, 3, 10, 13, 17. And it didn't have to be in order. But y'all agree that A complement is everything in the universal set except A? Okay. So that's what we mean by A complement. Okay? All right. Now, not difficult. Not difficult. As long as you know the definition, it's fairly easy to deal with. Okay, now let's look at the example now. So let's write this example 1. Suppose that this is my universal set. So I'm not drawing as a Venn diagram. In fact, don't. It's easier just to leave it as in roster form. So let's suppose that your universal set is 3, 5, 7, 9, 11, 13, 15, 17. So that's my universal set. Okay, so 3, 5, 7, 9, 11, 15, 13, 15, 17. And let's suppose that set A is this. 5, 9, 13, 15. Okay? Now let me ask you this though, or let me remind you about this. So use a universal set. Hold on. Use a universal set, right? So should A be a subset of the universal set? Should A be a subset of the universal set? Yes, it better be. Look at the Venn diagrams, guys. Is set A inside the universal set? Yeah. So just make sure that as I'm doing those examples, I write the correct number. So is 5, 9, 13, 15 inside here? 5, 9, 13. Yeah. All right. So we're good so far. Okay. Now, here's the question. Find a complement. Find a complement. Here's the best way to do this. Now listen, the best way to do this is to go to the universal set. Now remember, the A complement means everything in the universal set except what?
A.
Except A. So go to universal set and cross out A. So what do I cross out in that universal set? 5, 9, 13, 15. Okay? So therefore, what's left? 3, 7, 11, and what? 17. So that's a complement. That's the way to do it. Okay? But you understand what the complement is? Okay. What was your question?
Yeah, you answered.
Okay. All right. Okay? Now, let's look at this. We're going to look at objective number 2 now. Objective number 2 is this. So objective 1 was to understand a complement. All right. Objective 2 is where we start talking about the intersection of two sets. All right, the intersection of two sets. So you already have an idea what that looks like. So I'm going to draw the Venn diagram again. And so here's my universal set. So this is my universal set. And then here's set A. Here's set B. So the symbol, when I write this right here, looks like an N. That means that A intersect B. Okay? A intersect B. So in terms of the Venn diagram, what part of that Venn diagram would I shade to indicate the intersection of A and B? Yeah, the one you say the middle, this right here, right? Okay, so that right here indicates A intersect B. So listen carefully to the definition, and we're going to use the set builder notation in it. That's be important to see it. So definition of intersection of two sets. Definition of intersection of two sets. All right. So the intersection of sets A and B, and it's written as what we just showed you. Okay, so remember that means A intersect B, the intersection of sets A and B is this. And we had the discussion earlier. So if I'm looking at the intersection, then that means that whatever's in here, whatever's in that shaded region is in two places, is in A and what else? And B. Okay? It has to be in both A and B for it to be an intersection. So remember that the number 4? Okay, so that's why 4 was in that shaded part earlier. So it's the set of elements. So the intersection is a set of elements that is common to both A and B. Set of elements that is common to sets A and B. Okay? So if the number 5 is the intersection, that means that 5 has to be in set A, and it also has to be in set B. Now here's what set building notation looks like for this. Okay, listen carefully to this. So A intersect B means this is a set of x's, whatever x may be. It doesn't have to be natural numbers. It could be words. It could be colors, letters, whatever. So I'm not going to put natural numbers here because it could be anything. So here's how we're going to denote it. The set of x's, whatever x may be, such that x is an element of A and x has to be an element of what? B. So that's your set builder notation. So the intersection means that x is an element of A and it's also an element of what? B. All it is. Okay? Not difficult. You can visually see in the Venn diagram what that looks like. So let's just real quickly do this then. Okay, look carefully at this. What? Okay, example. Find each of the following intersections. Find each of the following intersections. Find each of the following intersections. Letter A. Okay, so there are quite a few numbers, so just do the best you can with this. 1, 3, 5, 6, 8, 12, and 14. So that's your first set. So 1, 3, 5, 6, 8, 12, and 14. And I'm intersecting it with this set. 2, 3, 7, 8, 13, 14. That's a 14. So 2, 3, 7, 8, 13, 14. So what do you think the answer is? What set? What am I looking for?
The numbers that are the same.
The numbers that are common to both. What are they? 3, 8, and 14. Good. So 3, 8, and 14. So you answer? Three, 8, and 14. Now you got to make sure you write as a set. So when you write as a set, you got to use that brace, right? Write as a set. Okay, B. One, 5, 8, 9. There's your first one. And you want to intersect it with the other one. 2, 6, 10. 1, 3, 5, and 9. So the set that has those 4 elements, and you want to intersect it with a set that has the other 3 elements. What's the intersection? Okay. There's a better word to use than saying there is none. What's the word? Empty set. Yep. Empty set. So it's the empty set. So the answer, you can use a symbol for empty set, which is this, or you can just say empty set. All right, now C. One, 2, 3, 4. Intersect this. All right, now be careful with that one. Okay? So in letter B, they had no elements in common, so that was the empty set. They had no common elements. In B, though, be a little bit careful. So you have how many elements in here? 4. This has no elements in it, right? So you really can compare the two because there's really no elements inside of this. So the best way to say this is by saying no common elements, or you can say what word? Or what symbol? Empty set. Alright? So this has 4 elements, this has how many elements? None, there's nothing in it. So obviously there's not going to be anything in common, right? So no common element, or you can just say what? Empty set. Okay? Alright. So if you have a set, intersect the empty set, then it's automatically what? Empty set. Okay? Alright, question. Not difficult. Okay. Yes.
So empty set can be like empty brackets with like nothing in it.
Yeah.
Circle with a
Yeah.
dash,
Yep.
just
So
right.
you can say this, or you can say that. So remember, they mean the same thing. Yeah. The same thing there in the other one. You could do this, or you can say that, because they all mean the same thing. All right. Any questions on the intersection? Okay. So you got the intersection. Let's talk about union. Union's easy as well. Talk about union. So this is objective 3. So the union of 2 sets. Okay, so probably the best thing to do is to look at this Venn diagram. And I'm going to just go ahead and kind of overlap them like this. And let's call this A, this B. And in this Venn diagram, I'm not going to put a lot of numbers in there. Let's say this is a 1 here, this is a 2, this is a 3, this is a 4, this is a 5, 6, 7. So go ahead and do that. So as a quick review, though, from what we just talked about, tell me what this would be. What would that be? 3, right? Intersection. Okay. So you have an idea what intersection is, or you know what intersection is. Now let's talk about union. So here's our definition of union. So intersection was that if X is an element of A, intersection. If X is an element of A, then it must also be an element of what? B. Okay, that was intersection. Let's talk about union with this case. So here's a definition of union, and then we're going to come back and look at this. So definition of union of 2 sets. Okay, so the union of sets A and B, the union of sets A and B, and here's how it's written. Remember that intersection is that upside down U? So union will be, it looks like a U. So intersection looks like an N, union looks like a what? A U. So that's how, so A, U, B means the union of 2 sets. If it looks like an N, then it means the intersection of 2 sets. So A union B, and this is what it means, is the set of elements that are members of A Okay, now before I go on, let's think about our definition of intersection. Remember, intersection was this. I'm going to start right here. Intersection, think intersection. Is the set of elements of, now, or members of A, and what word did I use after that? And members of B. That was intersection. So I use the word and, right? Union means this. The set of elements that are members of A are elements of what? B. Okay? So either they are in A or they are in what? B. Okay? All right. So let's go to our example. Let's see if you understand the definition. Oh, and by the way, set builder notation looks like this. So A union B would equal the set of x's such that x is an element of A, and what word do I use instead of and? Or x is an element of what? B. All right. So instead of using the word and, I'm using the word what? Are. So let's look at our example right here. Number 2, A union B. So I'm going to write this as a set. So the union of set A and B would be any element that's in A or in what? B. So, and again, remember, when you do this, you don't have to put them in a certain order, but let's go ahead and put them in numerical order. So what do you think would be my elements? 1, 2, 3, 4, 5. Do I keep on going or I stop? I can't use 6 or 7, right? Why can't I use 6 or 7? Because 6 is not in A or B and 7 is not in A or B, right? So that's it. Now you may say, well, what about 3? 3, I thought 3 was the intersection. Well, but remember the definition of union. The number has to be in A or it has to be in where? B. Well, is 3 in A? Yeah. Is 3 in B? Yeah, it doesn't matter, it's in both. Okay? All right, you understand what union is? Okay? All right, we're almost done, and I'll get you started on some stuff. All right, so I want you to do this for me. Let's look at this example. Okay, example. Find each of the unions. Find each of the following unions. Letter A. 7, 9, 10, 13, 15, 18. That's one set. So 7, 9, 10, 13, 15, 18. Union 5, 7, 10, 13, 17, 18. So 5, 7, 10, 13, 17, 18. Okay, now union, not intersection, union. So the union would be anything that's A and also anything that's where? In B. That would be union. So everything that's there. If it's listed in A and listed in B, we only listed once. Okay? So it doesn't have to be in order, but let's just, what I would do, since it's over the place right here, what I would do is I would say A union B, well actually the union, I would just put them in the order I see it. So I need a 7, what else do I need? Well, 9, right? What else? 10, what else? 13, what else? 18, now let's do the B. What else do I need? 5. I need a 7, which I already have, right? Let's go to the next one. I need a 10, which I already have. I have a 13. Which one to do it? What's the only thing I need to write? 17. So that's your union. You understand the idea of union? Okay. And let's put an empty set in there, just like we did with intersection. Let's do the empty set. Okay, so 2, 3, 8, and 9. Union, the empty set. Now remember, the intersection was the what? Of a set and an empty set. The intersection was the what? Was the intersection of a set and an empty set.
Empty set.
Empty set. What's the union of a set and the empty set?
The set.
The set. Because remember the definition of union says my set, my answer is going to be everything that's in the first set and everything that's where? The second set. All right, well, let's look at that. So it's my answer will be 2, 3, 8, 9. Now let's go to the other set. Well, there's nothing in the other set, right? So I'm done. So basically, I want you to think about what we just did with the empty set. Okay, listen carefully. So for any set A, here's what we just saw. A intersect the empty set was what? Come on, guys. A intersect empty set. What was that? The empty set. Number 2. A union the empty set. What is that? Huh? A. Remember, with union, so I have a set, I have an empty set. When I union those, it's just my what? Set. So A union the empty set is whatever A is. A intersect the empty set is the empty set because they have nothing in common. Okay? All right. Now what we're going to do, you still have 20 minutes. You can't leave just yet. Otherwise, I'll continue on. Huh?
We got 5 minutes.
Oh, you're right. It ends at 10:15. I mean, 1:15. Oh, good Lord. I thought it ended at 1:30. So you start 10:30? No, you're right. I'm so sorry.
I had a major stroke.
I know, right? Oh, my goodness.